Okay, so this lesson focuses in on adding and subtracting square roots. And before we add and subtract square roots, one of the things we have to remember is the idea of combining like terms. So when we add and subtract square roots, we're going to be looking at combining like terms. Combining like terms. Okay? And so let's review something that we've learned before. So these are like terms right here. So I can combine these terms. So 3x plus 2x. So those are like terms. Remember that? So remember like terms. These are like terms because they have the same variables. These two terms, there are two terms. They have the same variables, and those same variables are raised to the same power. All right, x to the first, x to the first. Doesn't matter what the coefficient is. And so when we combined them, we had 3x here, 2x here, and that became 5x. Okay. We also saw something like this where we had 7x squared minus 3x squared plus x squared. So notice that all these three terms are like terms. They all contain the variable x raised to the same power, x squared, x squared, x squared. And what we did when combining these like terms was we added their coefficients. 7 plus a negative 3 is 4. 4 plus 1 is 5. So it became 5x squared. Okay? So notice that in these two examples, both terms were alike, and all these three terms were alike. But then you also did something like this. So let's call this example 1, example 2, example 3. So this is a kind of like a quick review from a previous lesson / course. Okay, now listen to this. What if you had this? What if you had negative 3x squared minus 5x plus 2x squared plus 4x plus 3x minus 1. All right, so I know I have a lot of terms here, but you've dealt with this before. First of all of these terms like terms. Notice I have 1, 2, 3, 4, 5, 6 terms. Are all of those like terms? No. But what you did was you combined like terms, right? So the only like terms here in terms of x squared would be a negative 3x squared and 2x squared. Do you agree those are like terms? Okay. So a negative 3x squared and a positive 2x squared gives me negative 3 plus 2 is what? Negative 1. So that becomes negative x squared. Then you have a negative 5x, and I can combine it with 4x and 3x, right? So those three are like terms. Those three are like terms. So what's a negative 5x and a positive 4x? A negative 5 and 4 is a negative 1. And what's a negative 1x plus 3x? That's 2x, positive 2x. And then the only thing I have left is this constant. Okay? All right, so that was a quick review of combining like terms. Now, we can use this idea with something like this, with square roots. We can use this idea with square roots. So, for example, listen carefully. Add, subtract. That's going to be the directions. Add, subtract. Okay, number 1. Suppose I had 11 square root of 7 minus 4 square root of 7. 11 square root of 7 minus 4 square root of 7. So whenever you're adding or subtracting square roots, or cube roots, or fourth roots, whatever it may be, but we're focusing on square roots here, treat the square root like a variable. So see how this is a square root of 7 and this is a square root of 7? So think of that like 3x and 2x. All right? So do y'all agree? Do y'all agree that if I had 11x minus 4x, y'all would say that would be, what's that, 7x? Is that correct? Okay. So my question to you is this. Then what would be 11 square root of 7 minus 4 square root of 7? 11 square root of 7 minus 4 square root of 7. Well, that would be 7 square root of 7, right? 7 square root of 7. Okay? Now, let's go back right here and ask you this. Are these like terms? Are these like terms based on our discussion? These right here. 5 square root of 3 plus 2 square root of 7. Are these like terms? No, those are not like terms. Those are not like terms because whenever you're dealing with square roots, you got to make sure that when you're dealing with square roots are like terms if the radicands are the same, because the radicands are different. They're not like terms. Radicands are different. Okay? Not like terms because the radicands are different. Okay? So the radicands the same? Yes. Now, remember we are dealing with square roots, right? So I got to say something a little bit further with this, just in case you get into this situation. So, are these like terms? No. What about these? 6 square root of 5 plus 7 cube root of 5. Are those like terms? No. Those are not like terms. And you might say, well, you just said that if the radicands are the same, they're like terms. I did say that. But we're dealing with square roots, right? What do you notice about the indices? The index. Here's 2. The index is here is 2. But what's the index here? 2. What's the index here? 3. So I can combine like radicals. I can combine radicals. Let's just say like this. I can combine radicals if two things occur. If the indices are the same, are equal, and the radicands are equal. Okay? So the indices have to be the same and the radicals have to be the same. Okay? So what's the index on both of these? 2, square root. What's the radicand? 7. So they're the same, right? So it's 11 square root of 7 minus 4 square root of 7. 7 square root of 7. Okay? Number 2. Okay, now be careful. Number 2, listen carefully. What is 6 square root of 5 plus 2 square root of 5 plus 7 square root of 2? Okay? How many terms do you see? There are 3 terms, right? 1, 2, 3. Based on our discussion right here and based on our discussion here, can I combine all of those 3 terms? The answer is no, because I can combine radicals if the indices are the same, are equal, and the radicands are equal. So see here, I could these 2 here, they're not like terms, right? Because the radicands are the same, but what's the problem? The indices are different. That's a 2, that's a 3. So let's talk about this. Are these 2 alike? Yes. So I can combine these 2, right? So what's 6 square root of 5 plus 2 square root of 5? Well, 6 square root of 5 plus 2 square root of 5 is how many square root of 5s? 6 plus 2 is 8. So you get 8 square root of 5, and then just write this over. And there's your answer. Okay? So you understand a little bit better, right? Okay? Okay, what about this? Suppose we had number 3. 3 square root of 5 minus 5 square root of 5 plus 6 square root of 2 minus square root of 2. All right, so I have 4 terms, 1, 2, 3, 4. These are alike because they both contain square root of 5s, right? And then these 2 are alike. So let's talk about these 2. What's 3 square root of 5 minus 5 square root of 5? Okay, negative 2 square root of 5. What's 6 square root of 2 minus square root of 2? 6 minus 1. That's a 1 right here. 6 square root of 2 minus 1 square root of 2 is 5 square root of 2. So there's your answer. Okay? All right, now let's look at this. Okay, now that you know what like terms mean in terms of square roots, okay? Because we're dealing with square roots here. Now that you know what like terms mean in terms of square roots, let's do the next one. Okay, number 4. All right, now number 4, suppose we had this. Suppose we had the square root of 20 minus the square root of 5. All right, so that's where you're going to have to start thinking about problems you had in a previous lesson. Square root of 20. Now you may say, well, those are not like terms. Yeah, that's true. But you need to ask yourself, first thing you got to do is can you simplify the radicals? Can I simplify the radicals? See, in these, I couldn't simplify because what's the only perfect square? I mean, we're dealing with square roots, so think perfect square. What's the only perfect square that goes into these two radicands? 1. What's the only perfect square that goes into all these radicands? 5, 5, and 2? 1. What's the only perfect square that goes into 5, 5, 2, and 2? 1. But you remember in a previous lesson you looked at the square root of 20? What's the largest perfect square that goes into 20? 4. So you can write this as square root of 4 times square root of 5, right? And what's the square root of 4? 2. So that's 2 square root of 5. So the square root of 20 becomes 2 square root of 5 minus square root of 5. Now do you see that those are like terms? Okay. So when adding and subtracting fractions, most times you will have to simplify the radical first before looking for like terms. So what's 2 square root of 5 minus 5 square root of 5? Well, it's just square root of 5. Okay. All right, number 5. Suppose you had, let's say, the square root of 98 minus 3 square root of 2. The square root of 98 minus 3 square root of 2. Okay, so I know that those are not like terms how they look, right? But then you want to make sure, can I simplify the radicals? Well, let's look at 98. What's the largest perfect square that goes into 98? All right, think about the square root of 98. Do y'all agree that I can write this as square root of 49 times 2? Right? What's 49 times 2? 98. So that becomes the square root of 49 times the square root of 2. And the square root of 49 is 7, so you get 7 square root of 2. Now I want you to think about this for a moment. So you know right now we're dealing with adding and subtracting square roots, right? So if you look at this, can I simplify the square root of 2? No. But then you're going to ask yourself, can I simplify this? So chances are, that's not always true, but chances are when you simplify this, you're going to have a square root of 2 here. Not always, but chances are. So what I would do is this. If I see that this is something I cannot simplify, then I'll take this radicand, 98, and divide it by this radicand, 2, and notice I get a perfect square. So that's what I would use. I would use 49 times 2, and 49 is the largest perfect square. Okay, so the square root of 98 becomes 7 square root of 2 minus 3 square root of 2. And what's 7 square root of 2 minus 3 square root of 2? Well, that's going to be 4 square root of 2. Okay? All right, number 6. Okay, suppose you had 3 square root of 12 minus 2 square root of 48. Okay? 3 square root of 12 minus 2 square root of 48. Okay, now, so obviously the way they look, those are not like terms because that radicand's 12 and that radicand's 48. The indices are always going to be the same because you're dealing with square roots. So you got to ask yourself, can I simplify any of these radicals? All right, so that's where you have to go back. You have to go back to a previous lesson where we simplified the square root of 12. What's the largest perfect square that goes into 12? That's easy. What is it? Okay, good. 4. So that's the square root of 4 times the square root of 3. And what's the square root of 4? Okay, 2. And so you get 2 square root of 3. So that right here, now be careful, that right here becomes, don't forget the 3. That's 3 times, and the square root of 12 is this, 2 square root of 3. Now let's look at 48. So always look for a largest perfect square. Now you see I have a 3 right here. I have a 3 right here. What I would do is I would divide this 48 by 3. And let's see what we get. 48 divided by 3, 16. And 16 is a perfect square, right? So I'm going to go off to the side. I'm going to look at 48, square root of 48. So square root of 48 will be the square root of 16 times the square root of 3. You see you have the square root of 3 in common? Okay? And so that's 4 square root of 3. So this becomes minus 2 times 4 square root of 3. Okay? And then what's 3 times 2? 6. So you get 6 square root of 3 minus, and then 2 times 4 is 8, right? So you get 8 square root of 3. Those are now like terms. So it's 6 square root of 3's minus 8 square root of 3's. Well, that's going to be a negative 2 square root of 3. Okay, number 7. So number 7, suppose you had 2 square root of, let's say, let me think, 2 times the square root of 18 minus the square root of 27 plus 4 square root of 3. Okay? So 2 square root of 18 minus the square root of 27 plus 4 square root of 3. Okay, now let's look at the square root of 18. Now, first of all, if you look at those three, can I simplify this one? No, cannot simplify this one. So let's look at these two. Let's look at square root of 18 for a moment. Square root of 18. What's the largest perfect square that goes in 18? Okay, 9. So that's square root of 9 times square root of 2. So that's 3 square root of 2, right? So that goes here. Oops, so that's going to be 2 times 3 square root of 2. Y'all agree? Square root of 18 is 3 square root of 2, right? Let's look at 27. What's the largest perfect square that goes into 27? Okay, 9. So that's square root of 9 times square root of 3, right? And the square root of 9 is 3, so that's 3 square root of 3. So it becomes, this right here is this. So that's 3 square root of 3, and then plus 4 square root of 3. All right, so that's where I'm at. Now let's go ahead and multiply 2 and 3. So that's 6. So I get 6 square root of 2 minus 3 square root of 3 plus 4 square root of 3, right? I have 3 terms. Are all of these like terms? You better say no, because that's square root of 2, and these are square root of 3's. These are like terms. So let's look at these right here. So I cannot combine this with anything, so I'm going to rewrite it. Now what's a negative 3 square root of 3 plus 4 square root of 3? What's a negative 3 and 4? It's just 1. So you just get plus square root of 3, right? So that's the answer. Right. Don't make the mistake, because this happens. Don't make the mistake and say this. 6 square root of 2 plus the square root of 3. This is not true. Okay, not true, not true. Some students are going to say this. That's 6 square root of 5. That's not true, okay? Because the square root of 2 plus the square root of 3 is not the square root of 5. Don't make that mistake. That's not true. You can see that's not true. Look, try this. The square root of 2, close the parentheses, plus the square root of 3, close the parentheses, and that equals about 3.15, right? So that's about 3.15. The square root of 5 is about 2.24. So you see, that's not a true statement, so don't make that mistake, okay? You're done. This is your answer. Leave it like that. Okay, you are done. Now, if you wanted to put, remember addition is commutative, so if you wanted to put, let's say, the square root of 3 plus 6 square root of 2, that's fine as well. All right, does not matter. All right, just be careful about this, though. Remember, this is not true. Okay? All right, number 8. Number 8, let's suppose we had this. All right, number 8. Let's suppose we had 2 square root of 45 minus 2 square root of 20. Okay? And let's say plus 3 square root of, let's say 3 square root of 5. Let's do that. Okay, now, you have 3 terms. Are all of those 3 terms alike? No. That's square root of 45, that's square root of 20, that's square root of 5, right? All right. Now, let's simplify the square root of 45. Let's think about the square root of 45. What's the largest perfect square that goes into 45? Okay, 9. So you agree that's the square root of 9 times the square root of 5? So that's going to be 3 square root of 5. So this becomes 2 times, and remember the square root of 45 we just found. And then 2 times 3 is 6. That's 6 square root of 5. Y'all agree? All right, let's go to the next one. Square root of 20. Square root of 20 was the largest perfect square that goes into 20. Okay, 4. So it'll be the square root of 4 times square root of 5. The square root of 4 is 2, so you get 2 square root of 5. So that goes here. So minus this 2 times, and remember the square root of 20 is 2 square root of 5. And then 2 times 2 is 4. Y'all agree? So that'll be minus 4 square root of 5. And then don't forget, can I simplify this? No. Okay, now look at all these three terms. Are all these three terms now alike? Yes. So remember in the previous problem, we had three terms. Only 2 were alike, right? And notice how it looked. Okay, so these terms are not alike anymore, right? So you're done. You can't go any further. And then over here, they're all alike. So let's think about this. What's 6 subtract 4? So y'all agree that this is going to be 2 square root of 5s? And what's 2 plus 3 square root of 5? 5 square root of 5. So that's 5 square root of 5. Okay? All right, so notice you have to simplify all the way until you see how that 5, the only perfect square is 1 that goes into this. The only perfect square that goes into 5 is 1. Okay? You got to go further. See, this was not simplified. You have to simplify. So the first thing you got to do is make sure you simplify your radicals. Okay, number 9. All right, number 9, let's suppose you had the square root of 50 minus 7 square root of 32 plus 4 square root of 12. All right, so square root of 50 minus 7 square root of 32 plus 4 square root of 12. All right, so notice that if you look at those three terms, those square roots in particular, they can all be simplified. So let's look at the square root of 50. What's the largest perfect square that goes into 50? All right, 25. So it'll be the square root of 25 times the square root of 2. What's the square root of 25? Okay, 5, so you get 5 square root of 2. So that's this. So this is 5 square root of 2, right? Let's look at the square root of 32. What's the largest perfect square that goes into 32? You got to know that. You got to know those. You got to use the largest. It makes things a lot easier for you. 16. So it'll be the square root of 16 times the square root of 2. The square root of 16 is 4. I can't simplify the square root of 2 any further, so it'll be just 4 square root of 2. So that becomes minus 7 times 4 square root of 2, right? Plus, let's look at the square root of 12. What's the largest perfect square that goes into 12? 4. So it becomes the square root of 4 times the square root of 3, right? Okay. Square root of 4 is 2, so you get 2 square root of 3. So that goes here. So that's 4 times 2 square root of 3. Y'all agree? All right. So I get 5 square root of 2. 7 times 4 is 28, right? So I get minus 28 square root of 2. And then 4 times 2 is 8, so I get plus 8 square root of 3. So now, see, all of this is simplified now. I'm done with simplifying the radicals. The only perfect square that goes into 2 is 1. The only perfect square that goes into 2 is 1. The only perfect square that goes into 3 is 1. Now, are all these like terms? Are all of these like terms? No. Which ones are like terms? The first two. So what's 5 square root of 2 subtract 28 square root of 2? Well, that is a negative, what's that, 23 square root of 2? And then plus 8 square root of 3. Okay? Don't combine those. Those are not like terms, so you're done. Now, if you wanted to do this first, if you want to rewrite it, you could. You could say R8 square root of 3 minus 23 square root of 2. Does not matter. Both of those are the same thing. Okay? Number 10. Suppose in number 10 you had this. Let's say we had let's say we had 3 square root of 24 minus 2 square root of 54 plus the square root of 6. All right, so 3 square root of 24 minus 2 square root of 54 plus the square root of 6. All right, so if you look at those square roots, they're not like terms so far. But remember, the first thing you have to do is you got to simplify the radicals. Simplify radicals. Okay? Now, the square root of 6, if you look at the square root of 6, the only perfect square that goes into 6 is 1, so I can't do anything to that one. But let's look at the square root of 24. What's the largest perfect square that goes into 24? Besides 1, it is 4. So I can write this as the square root of 4 times the square root of 6. And the square root of 4 is 2, so this becomes 2 square root of 6. All right, and I can't simplify this any further. So this becomes 3 times 2 square root of 6. Square root of 24 is 2 square root of 6. Let's look at square root of 54. All right, so use your calculator if you need to. Let's think about 54. So 54, you see how I have a 6 here? Let's go ahead and divide by 6, see what happens. Divide by 6. Hey, I got 9. And is 9 a perfect square? Yep. So 9 times 6 is 54, and 9 is the largest because 6, the only perfect square that goes into 6 is 1. So this becomes the square root of 9 times the square root of 6. And so that's 3 square root of 6. So this becomes minus 2 times 3 square root of 6 plus the square root of 6, right? Now let's go ahead and multiply what we can so far. 3 times 2 is 6, so that's 6 square root of 6 minus 6 square root of 6 plus the square root of 6, right? Okay. So if you look at this, what's 6? First of all these 3 like terms? Yes, they all have square root of 6. What's 6 square root of 6 minus 6 square root of 6? 0. What's 0 plus the square root of 6? Square root of 6. There's your answer. Okay, it's not too bad. You just got to remember something from a previous lesson about simplifying radicals, and then just knowing what we mean by like terms in terms of radicals, what like terms are. Okay? All right, let's look at number 11. So in number 11, you have, let's say we have 2 square root of 50 plus 3 square root of 18 minus the square root of 32. So 2 square root of 50 plus 3 square root of 18 minus square root of 32. Okay? All right, now, so let's simplify each radical. So obviously I can't combine any of those because they're not alike. And then again, the first thing you got to do anyway is simplify the radicals. So the square root of 50 becomes 20. I can use 25. That's the largest. So 25 times square root of 2. Square root of 25 square root of 2. And so that's 5 square root of 2. So it becomes 2 times 5 square root of 2, right? Over here, square root of 18. What's the largest perfect square that goes into 18? Okay, 9. So that'll be the square root of 9 times square root of 2. So that's 3 square root of 2. So that'll be plus 3 times 3 square root of 2, right? Minus, and then let's look at the square root of 32. The largest perfect square that goes into 32 is 16. So it'll be the square root of 16 times the square root of 2. So that's 4 square root of 2. Square root of 16 is 4. And then 2 times 5, let's go ahead and simplify even further. 2 times 5 is 10, so that's 10 square root of 2's over here. This is 9 square root of 2's, and this is minus 4 square root of 2's. Notice that all these like terms. Yes, they're all like terms. So 10 square root of 2 plus 9 square root of 2 is 19, right? So that's 19 square root of 2. And then 19 square root of 2 minus 4 square root of 2 will give me, what's that, 15 square root of 2? And so that's your answer, 15 square root of 2. All right, number 12. Let's suppose in number 12 I had, let's say, the square root of 63 minus 2 square root of 28 plus 5 square root of 7 plus 4 square root of 12. Okay? All right, so square root of 63 minus 2 square root of 28 plus 5 square root of 7 plus 4 square root of 12. Okay, now I have 4 right here. Can I simplify all of those? Or which one can you see right away you can't simplify? This one, right? Because that's a 7. The radicand's a 7. The only perfect square that goes into 7 is 1. All right, so let's look at 63. Square root of 63. Let's see if I can simplify that. You see how this is a 7? Let's just use it. Let's just use it for a moment. So 63 divided by 7 gives me 9, and 9 is a perfect square, so I'm going to get 9 times 7. So that'll be the square root of 9 times the square root of 7, right? So that becomes 3 square root of 7. So this is 3 square root of 7 minus, all right, let's look at the square root of 28. Now 28 is easy to where you can tell me what the largest perfect square is. What's the largest perfect square that goes into 28? 4. So it'll be the square root of 4, square root of 7. Hey, we get that square root of 7 again, right? Square root of 4 is 2, so you get 2 square root of 7. So that'll be 2 times 2 square root of 7. This is already square root of 7. Now let's look at square root of 12. What's the largest perfect square that goes into 12? 4. So it'll be the square root of 4 times square root of 3. Square root of 4 is 2, so you get 2 square root of 3. So it becomes 4 times 2 square root of 3. All right, so the square root of 12 is 2 square root of 3. Now let's go ahead and simplify what we can at this point. So that's 3 square root of 7. Now when I say simplify, I mean rewrite this. So that's 2 times 2 is 4. So that'll be minus 4 square root of 7 plus 5 square root of 7 plus, and then 4 times 2 is 8 square root of 3. I have, now, can I simplify any further? Can I simplify the radicals? Can I simplify the radicals any further? No, because the only perfect square that goes into 7 is 1. The only perfect square that goes into 7 is 1. The only perfect square that goes into 7 is 1. The only perfect square that goes into 3 is 1. But I can combine these because they all are the square root of 7. So what's 3 square root of 7 minus 4 square root of 7? Let's look at that first. So 3 square root of 7 minus 4 square root of 7. Do y'all agree that's negative square root of 7? I'm going to rewrite the rest over. Y'all agree? Okay. What's a negative square root of 7 plus 4 square root, plus 5 square root of 7? Remember, that's a negative 1. So a negative 1 plus 5 is 4. So that's 4 square root of 7 plus 8 square root of 3. And then you're done, right? Can I combine these? No. That's 7. That's 3. So you're done. Now, if you want to, you can rewrite it as 8 square root of 3 plus 4 square root of 7. Okay, either one's fine. All right, so again, the prerequisite for this, though, guys, was the lesson on simplifying radicals. That was a lesson. There was a worksheet on that as well. And in this lesson, you're just doing the same thing. You're simplifying the radicals, but you're combining like terms. It is very important. It is very important. You know what we mean by, in terms of radical, what like terms are. So remember, you can combine radicals if the indices are the same, and you are dealing with square roots here, so the indices will always be the same, and the radicands must be equal. Okay? All right, so that's the lesson on adding and subtracting square roots.